All right, we're going to go ahead and talk about direct variation. And this is found on page 26. Now, direct variation, very simply put, is a linear equation that goes through the origin. Okay? Now, the direct variation equation is y is equal to a times x, where a is the constant of variation. All right, and you should notice that this looks very similar to what we were working on with slope-intercept form, right? Y is equal to mx plus b when b is equal to 0. All right, this is the same thing, right? Y equals mx if this was just 0. Really, it's the same thing, okay? It's just when there's no y-intercept, which makes sense. We said a second ago that when it goes through the origin, it's showing direct variation. Well, it's the same thing here. When b is equal to 0, that's when we can go ahead and see a direct variation relationship, okay? Where y varies directly with x. We'll see that phrase a lot as we go on. So on that page 26, you're going to see two different equations. And our task here is to say, is this an example of direct variation, okay? And what we're going to do is try to get it into this form, right? Put it into slope-intercept form where y is by itself and see if there's any y-intercept other than 0. All right, so we need y by itself. So I'm going to go ahead and subtract 4x. Oops, sorry about that. I did both on the same side. Minus 4x on both sides. So we have 2y equals negative 4x divided by 2 to finish getting y by itself. So here y is equal to negative 2x. So because this sits in the same form as y equals ax and the y-intercept is 0, this is direct variation. I'm going to go ahead and write yes, direct variation. And for bonus, I don't remember if I asked for this on the problem, but it says to state the constant of variation if so. So we'll say that a is equal to negative 2. Okay, great. Now let's come over to the next one. Same thing, we want to get y by itself. So we're going to go ahead and add 2x to both sides. So we have y equals 2x plus 3. Okay, we've isolated y, and you know what? It looks more like this. We have a y-intercept of 3, not 0. So this is not direct variation. So we'll write not direct variation. Okay. All right, let's keep moving. If you turn the page, there we go. If we turn the page, okay, the next one says to graph a direct variation equation. All right. Well, this is going to look just like when we graph slope-intercept form. Okay. There's a y-intercept here of plus 0. So we're going to go ahead and say that the y-intercept b is equal to 0. So let's plot it. Okay, there's our first one. Then we also have our constant of variation is negative 5. That functions just like a slope. So we're going to put negative 5 over 1. And this negative for the rise is going down, and then positive for the run is going to the right. So we're going to go down 1, 2, 3, 4, 5, over to the right 1. Okay, we're just doing a little sketch here. You can be a little more specific on your graph. Then we're going to go up 1, 2, 3, 4, 5, and to the left 1. All right, so now we can go ahead and connect this. Let's see if I can draw a straight line. Nope. Let's go ahead and just use the line function. This will work. There you go. Okay, mine does have arrows on the end. It's just a little small to see. So we do want to put arrows. There's no restriction on our domain here. We're just going to graph a line. All right, let's go ahead and keep going. Actually, what I would say is on your paper now, on page 27, the top has two problems like this. There's a checkpoint. I want you to do those two. And then also there's one more problem for you to graph. I want you to go ahead and do that one as well. Okay, so you could do that and then unpause the video so we can keep on going. All right, welcome back. Let's go ahead now and identify, actually I think on your paper it says this is a direct variation relationship or direct variation equation, and it wants us to find the actual equation. So if it did just give us a graph, we can identify that it is direct variation because it goes through the origin, okay? But now this is telling us it is direct variation. So because it's direct variation, we're gonna go ahead and take this, and we're gonna use this exact equation. Okay, we're gonna use this exact equation, and we're gonna look for the a value. We wanna plug in a, that's why I have it in yellow here. So something like y equals 3x or y equals 1/2 x. That's what we're looking for our equation. So luckily it gives us an x and a y point on our graph. We're gonna plug those in. So negative 3 is equal to a times negative 4, and let's solve for a, because that's the piece we're looking for. So a here equals a positive 3/4. Now don't fall into the trap that many students fall into. Okay, a lot of times they think, oh yeah, we're just solving for a. That's not what it asks for, okay? And again, this question actually doesn't match up what yours says on your packet. It should say, write the direct variation equation to match the graph. All right, let's make that smaller. There you go. So that's really, I think, what the directions were on this problem. Now we can go ahead and plug this 3/4 in for A. That's a terrible error. We're going to do y equals 3/4 x. That is our direct variation equation for this graph. Okay, so basically, again, just as I keep saying, basically write an equation in slope-intercept form. More or less is what we're trying to do. All right, now it also says if x was 80, what would y be? Well, we're going to go ahead and plug it in. Y equals 3/4 times 80. Okay, we can go ahead and cross cancel here, cross simplify. This becomes 20, and then our answer is 60. Y equals 60. All right, so when x is 80, y is 60. So we're going to see a lot more, we're going to do a lot more problems like this when it comes to actual word problems. Where you actually have to think about where you're plugging things in. But for right now, here you go. We have one more slide. So I want you to go ahead and turn to page 29. Yeah, 29. So you can go ahead, I'm leaving this information up here, okay? Let's go ahead and check out the tables on page 29. Now one of them, this one is already solved for you. This one right here is not. We're going to go ahead and do both of them. So there is one important thing that I want to go ahead and add for us to know that's going to help us with these problems. Okay, now one thing you might be able to do just by looking at a table to determine, if this shows direct variation. Well, remember, the main thing we know is that for something to show direct variation, it has a y-intercept of 0. Okay, so if you want to find a rule, you can find the function itself by doing rise or run and things like that. It's going to take a long time, but you can find out if it has a y-intercept of 0. Same thing here. The other thing you could do is, right now it seems like we're subtracting 3, right? So if we can get down to x being 0, right, 2, and this would be 8, this would be 1, this would be 5, and then 0, this would be 2. So right there, there's our y-intercept. It's 2. It's not 0. So therefore, this is not direct variation. But again, I'm going to give you another method. Okay, a method I think is much better. So what we're going to do is we're going to need to change this function so we get another format. Okay, a new format that's going to help us with these problems. And let me just move this over a little bit more. Yeah, there we go. All right, so we're going to go ahead and solve for a. All right, we're going to solve for a. So I'm going to divide by x. So we get a equals y over x. And we'll write this one more time, nice and neat. A is equal to y over x. Okay, this is important. Go ahead and box it, put it at the top of your page 29. Another good spot that might be to put it is to put it on the top of page 26, where this information was first given to you. Okay, add this other format as well, because again, it's going to be helpful. So let's use it here. In order for, we already know that this is not going to show direct variation, we just proved it another way, but let's use this one first and then we'll use it here too. So what we know is that a is equal to y over x. Y over x. So if we put our y over our x for all of these, they should simplify to the same thing. Oops, that's supposed to be a 4. If they do simplify to the same thing throughout, we have direct variation, and that is our constant of variation. So let's go ahead and just do it, and we'll make more sense of it. All right, here we go. 11/3, that's already simplified. 14/4, that should be 7 halves. Right here already we're getting an inclination that these are not, well, more than an inclination, these are not going to be the same. All right, these are not the same, these are not consistent, so therefore this is not direct variation. Okay, you can stop right there. Let's go ahead and use the same method for this next one. Okay, a is equal to y over x, we know that. So let's go ahead and try this one out. 9 over 3, which should equal the same thing as 12 over 4, which should equal the same thing as 15 over 5, which should equal the same thing as 18 over 6. All right, let's simplify them. So a is equal to 3, which is equal to 3, which is equal to 3, which is equal to 3. Awesome. So this means this is direct variation. So yes, direct variation. And we can go as far as to say, oh, we found our a value. All right, our a value is 3. So we can write y equals 3x. All right, so this separate format where we're solved for A could definitely be beneficial in working with these tables, and you can actually even use it in this next example. So feel free to use whichever one you prefer, but for tables, this is really probably the best method. All right, so the next one on this page, it says, given that y varies directly with x, oh, we already know that it varies directly with x, let's go ahead and use this formula, or this, the direct variation equation. All right, write the direct variation equation that relates x and y, which means we need to find that a value and plug it in. All right, we're basically looking for it in slope-intercept form. So let's go ahead and do it. You might have found here, since we're just looking for a, that using a equals y over x would be the better form here. It's up to you. I'll just use this one for now because I already copied it. A times 45, and we'll divide by 45. So a equals -1/5. Again, don't fall into the trap. Don't leave it here. We're looking for the direct variation equation for this problem. So therefore, it's y equals -1/5 x. This is our direct variation equation in this problem. All right, and that's it for right now. There are a couple word problems that we will work on, but we'll do that in class. I may make another video for it, but you know, I'm not for right now. And yeah, that's that.